Miss McCarter here. Today we're going to be learning about real numbers, and we're going to learn the difference between rational and irrational numbers. But first, we're going to start with something you guys already know. You've already learned about whole numbers. Whole numbers are numbers starting at 0 and counting by 1, all the way up until infinity. What you have to keep in mind about whole numbers is they cannot be negative, so no negative numbers. And also, you cannot have fractions. So -5 is not considered a whole number, -2 is not a whole number, and neither can fractions. So no fractions are considered whole numbers, which makes sense because 1/2 is not a whole, nor would 2.5 does not count as a whole number. Next, we have integers. So integers are similar to whole numbers, but the difference is they do include negative numbers. So -2 is considered an integer. It still does not include fractions. So -2.5 would still not be considered an integer, but -2 would be. Also remember that any integer we have here is still considered a whole number, okay? And then last on the left side is we have rational numbers. So rational numbers can be negative, just like integers, and then also rational numbers can be fractions or decimals. So that's the difference there. And we can see that all rational numbers are still, all whole numbers are still going to be considered rational numbers, as well as all integers are going to be considered rational numbers as well, okay? Now, the opposite of rational numbers is actually called irrational numbers. And let's just think about what those words mean, rational. So when you have a rationale, it's a reason, right? And irrational is oftentimes they don't have a reason, and we can relate that to our irrational numbers. So an irrational number is any number that cannot be made into a fraction. Any number that cannot be made into a fraction. So like we said, all of these numbers over here can be made into a fraction, right? Irrational numbers cannot. So now let's go back through each of our topics and give some examples of each one of our different real number categories. So for whole numbers, like we said, we can start at 0. What else can count as a whole number? 1, 2, 3, and we can count on forever and ever, right? Infinity, as long as we start at 0. After that, we move to integers. So remember, integers can include negative numbers, but still no fractions. So some examples of that would be -15, -3, 0 is still considered an integer, +5 is still an integer, but still no fractions, remember, or decimals. And then next we have rational numbers. So those can be our fractions and decimals. So we could have -8/2. We could have -0.2 repeating. We could have 2/3. So on and so forth. All of those numbers that can be made into a fraction or decimal. Irrational numbers are any numbers that cannot be made into a fraction. So they could be a decimal, but they're not going to be a nice and concise decimal. And I'll show you what I mean. One example of an irrational number would be the square root of 2. Another would be the square root of 3, and then pi. You have probably seen each of those numbers before and you didn't realize they were irrational. So let's take a look at what happens when we put those numbers into a calculator and see what they really represent. So here you can see at the top, we did the square root of 2 was actually 1.414213,562, and it actually doesn't stop there. It continues on forever and ever, which is why it's considered an irrational number. We can't give a nice round decimal to it or a fraction. Same with pi. Pi is 3.14159,265, and it goes on forever and ever. Same thing with the square root of 5 here. We see it's an ugly decimal that's going to keep going on and on. One thing that's different I wanted to point out to you guys, I have down here the square root of 9. Do we notice that that's a pretty and nice number? So we still have some square root numbers that are going to be considered rational, so you have to be careful with that. So now that we have gone over some examples of rational and irrational numbers and gone over all the different types of real numbers we have, I would like you to make your own graphic organizer. It can look similar to mine, it can be circles, it can be different. Make it your own, but make sure that you're including examples in each category. Thank you. Have a great rest of your day.